When finding the variance and then the standard deviation of a probability distribution, we can't just use the same old formula that we had done before. Now, to remember, variance and standard deviation basically tell us how spread out the data is from the mean. So we can find the mean, the average, this is what we think is going to happen, but how spread out is the data? Is it all clumped together in the middle, or is it really spread out? And that's what variance and then standard deviation, the square root of the variance, tells us. Now this is our formula we've used in the past. Variance is going to be you take what you're looking for here minus the mean squared, sum it all up, and divide by how many there are. And then the standard deviation is just the square root of that. The problem is with this dividing by how many there are. With probability distributions, basically we're saying the chance of this happening is this and is this and is this. We don't have a set number. So there's an algebraic way to show that this is equivalent, but here's the formula we're going to use. It says to find the variance of a probability distribution, we're going to multiply the square of each outcome times the probability, sum those up, and then subtract the mean squared. So again, what we're kind of doing here is to find the variance, we're going to square our values times our probabilities, add that all up, the sum of that, and then subtract our mean. We're still going to have to find the mean. I'm sorry, we're going to subtract the square of our mean. If we can get there, the standard deviation is pretty easy. We're just going to take the square root of whatever our variance is. It'll hopefully make more sense when we try an example. So a box contains 5 balls. 2 of those balls are numbered 3, 1 is numbered 4, and 2 are numbered 5. They're mixed up and selected at random. After it's selected, it records its number, then it's replaced. Then they do it many times, and they want to know what the variance and standard deviation of the number on the balls. Let's start with our distribution here. We're saying like x is the number on each ball. So what really is a probability of us pulling out a 3? Well, 2 of them are numbered 3 out of a total of 5. So we can say that this is 2/5. 1 is numbered 4. 1 of the 5 is 4, and 2 are 5. So we can have our probability distribution, and this is what we expect to have happen. If we do that, how far spread out from the data are they going to be? So again, if we go to our formula, and I'll rewrite this in a second, we still need to find the mean. So whenever you do these, start out by finding the mean. And to review, the formula for finding the mean of the probability distribution is the summation of our events here times the probability of those events. So if I wanted to find the mean of this distribution here, I'm really just going to go 3 times 2/5 summation plus 4 times 1/5 plus 5 times 2/5. And then just figure that out. This is 6/5 plus 4/5 plus 10/5. That ends up being 20/5, which we know is just 4. Alright, so we find our mean. Always start first by finding the mean. Then go ahead and find the variance. Our formula, and I'll just rewrite it because I don't have it here, is a summation of our x's squared times the probabilities. And if you look real quick, it's really, really similar to the mean, except this is squared here. And then we're going to subtract off the square of our mean. Do the same thing you did here, but we're going to square each of these. So I'm going to go 3 squared times 2/5 plus 4 squared times 1/5 plus 5 squared times 2/5. And then subtract our mean squared, and our mean is 4. It's what we just figured out. 3 squared is 9. 9 times 2 is 18. So we have 18/5. That's 16/5. 25 times 2. I know we can simplify that, but I'm just going to leave it for now. Works out to be 50/5. Minus 4 squared, which is 16. If you add all of this up, you get 84/5. which you're going to subtract 16. 84/5 is actually 5 goes into 18 16 times, and then there's 4 of the 5 left over, which I do realize we can change this to a decimal, but we're just going to leave it for now. We get our variance of being 4/5. Well, it asks us to find the variance and the standard deviation. Remember that we find the standard deviation because we've squared all of this stuff, so to get it back into its original form, we take the square root. So our standard deviation, remember, is the square root of 4/5. Well, 4/5 is actually 8/10. And that works out to be approximately 0.894. So this is just kind of an example of how we can find the variance and standard deviation of a probability distribution. Start by finding your mean. Use your formula, very similar to the mean, except you're squaring your x values here and then subtracting off the mean. Once you find the variance, you take the square root to find the standard deviation. Now remember, what standard deviation and variance mean is how spread out is the data If it's a normal distribution, remember 68% is going to lie within 2 standard deviations of the mean. If it's not normal, Chebyshev's formula says that it's going to lie within 1 standard deviation. 75% is going to lie within 2 standard deviations of the mean. And I believe I misspoke. I apologize. If it is a normal distribution, 68% of the data is going to lie within 1 standard deviation of the mean. If it's not a normal distribution, we have Chebyshev's formula, which tells us that the data will lie, 75% of the data will lie within 2 standard deviations of the mean. And we'll see how that can be used more in the next example.